All right, so we are going in chapter 1 for section 3 and 4 today. It's called multiplying polynomials and special products. This is for integrated math 2 or just IM2. So just to refresh on the screen here, remember when we open our homework, it's also going to give us a due date here. It doesn't give me that on the teacher preview, but you will see it on your screen. You always have unlimited attempts. So you can come in and complete this assignment as many times as you would like. This particular assignment has 10 questions on it. Our grading policy is always, best score. So, whichever attempt has the best score on it is the one that you get to keep, and you get partial credit. So if you have an answer 1 of 10 questions, you get credit for the 1 question. And always remember to submit your homework when you've started it, which is what this little please remember section's about. It's that submit assignment button in the bottom right corner. You always want to click submit whether or not you're completely done. Even if you've only done 1 of 10 questions, click the submit button. Number 1, it tells us what you're working on and how much you've completed. And number 2, it will not lock you out of assignments that way. Because if you do not click the submit assignment button, it will make you come back to this assignment to finish it. And it won't let you do anything else in your assignments or gradebook, or it just won't let you open anything else. So just be wary of that one. Once you click start here, there's always 3 buttons here. There might also be a calculator, but there's always going to be explanation, example, and message center. So explanation is going to explain this exact question to you. So it's going to tell you you're going to lose your attempt, and you're going to get a little red X on it, and you're going to have to come back on another attempt to do this one. It is a very cool feature because you can get this exact problem explained to you. So that's definitely very cool. There's explanation. So this will explain a similar problem. So it's just the problem type. It'll explain to you, they go through and they use FOIL here to do this. And there's multiple ways to do this type of problem, but they go ahead and use the FOIL method. And you can say, okay, I understand that. Once you go through and you've read it and you've taken your notes, you can close it. If you want another example, you can click an example again. It'll be a new example. You can also message your teacher with this exact question attached. So that's pretty darn cool because now we know exactly where you need help. All right, let's go ahead and get started on this one. So we're going to multiply. So let's go ahead and see what the FOIL method is. And this should sound pretty familiar. Most students have used the FOIL method. So it's just first, outside, inside, last. So it's just a way to remember that when you're doing FOIL. So first, and I'm actually going to color code this a little bit. Boop. Let's go with pink for the third one. And we'll go with kind of an orange for that last one there. Okay. So first refers to literally the first pieces in each of the sets of parentheses. So we say x times x and we get x squared. Outside refers to literally the farthest to the outside that you can get. So that would be the x and the -7. So we have x times -7, and that would get us -7x. Inside refers to the ones that you can get closest to the inside here. So it would be 5 and x. So 5 times x gets us positive 5x. And then the last one here we did in orange. So last means literally the last pieces, just like the first pieces. So we have 5 and -7. So 5 times -7 is -35. All right, let's go ahead and write this all out. I'll pick a completely different color here. So now we want to combine our like terms when we write this out. So -7x plus 5x. One's negative, one's positive. I'm going to subtract. Since 7 is bigger than 5 and it's negative, I know that's -2. All right, so this is what we want. This is our answer, our simplified answer. We can't go any farther than this yet because we don't know what it equals. So pretty soon we'll get the ending of that where it'll say equals 0, and we'll be able to continue the solving. There are more than one way to do this. So I have also just done this where I use distribution. And I focus on this x first, and I go x times x, and I get x squared. X times -7, and I get -7x. You notice it's still working out exactly the same. And then I go to the next one, and I go 5 times x, and I get plus 5x. 5 times negative 7, and I get negative 35. If you notice, this is exactly the same thing that happened up here. It's actually the same order. So I'm using FOIL. I'm just not paying attention to first, outside, inside, last. I'm just looking at the factors. I'm saying x, I'm going to multiply by each piece, and then 5, I'm going to multiply by each piece. So either way that works. There's also the box method. I know I'm giving you a couple of different things here, but you can use the box method, and I would have x plus 5, x and negative 7, and I literally use it like a multiplication table like this. So x times x is x squared, and I'd bring this over, and I'd have x times 5, and then I'd bring this down, and this guy over, so I'd negative 7x, and then negative 7 and 5 would come down, and that would be negative 35. Again, if you notice, these are the same 4 pieces I have right here. It's just a different way of looking at it. So there are so many ways to do the same type of problem. I definitely want you to do what makes sense for you. And for whatever reason, I've noticed this year, a lot of my IM2 students don't like FOIL. I think it's just kind of that very strict pattern. They don't like having to think about it in that way. And FOIL only works for a binomial times a binomial, which is what this is. So 2 numbers times 2 numbers. Once we start getting to bigger pieces, so like if we have a binomial times a trinomial, now FOIL doesn't work anymore because there's too many pieces. The first, outside, inside, last doesn't match up for every piece. So we would want to do something more like this in that situation. So it all depends on what makes the most sense to you, but there are multiple ways to do this. This would still work if we had a trinomial. All I'd have to do is add another box and say if I had, another piece here that I was adding or subtracting, whatever I'm doing there. So you can continue to make this box bigger and bigger and bigger if you need to. One cool thing about the box is the diagonals going from left to right here. So if I go like this, these should be like terms. So that's just a nice way to match that up. All right, so let's go ahead and type our answer in here. I think I've talked about this guy long enough. And again, I just showed you 3 ways to do the exact same problem. So it's just 3 different methods. And you just need to figure out kind of which one makes the most sense to you. All right, let's go ahead and check that. Perfect. So I'm not going to spend quite as much time on the next one. I'm just going to go ahead and start multiplying these ones. So 2x minus 1 and 7x minus 6. So I'm going to go ahead and use my, it's FOIL, but I just like to focus on it. So I'm going to use this 2x, and I'm going to multiply that by everything over here. So I'm distributing one piece at a time. So 2x times 7x. Remember, multiply coefficients first. So 2 times 7, we get 14. X times x, we get x squared. And then 2x times negative 6. Well, that's 2 times negative 6, so I get negative 12. And then I need to make sure I put the x on there. And the next piece is this negative 1. So I'm going to distribute this guy. So I end up with negative 1 times negative 7x. So that's, negative 1 times 7x gives me negative 7x. Losing my mind here, too much talking. And then negative 1 times negative 6 gives me positive 6. Now I just need to make sure I go through and I combine my like terms. So I'll write this in a different one. So my like terms should be in the center in this method. That's generally how it should work out. So 14x squared stays 14x squared. I have negative 12 minus 7. So they're both negatives. I'm going to combine them and keep the negative sign. Because I had 12 negative, I'm going 7 more negative. Plus 6. Alrighty, so that is a simplified trinomial here. Plus 6. Whoopsie! That shouldn't be up there, so I'm going to go ahead. Let's see, can I highlight it? I can. I'm going to copy it and drop it down and paste. So I just didn't want to have to retype it, but we definitely didn't want it up there in the exponent. All right, next. So we're just doing a couple of different practices of the same idea. All right, so I think, yep, I'm switched my colors up completely here, but that's all right. A minus B. Okay. So again, I'm just going to do that same thing where I'm focusing one factor at a time, or one term at a time. So 5A times 8A, you get 40 for my coefficient, and A times A is A squared. And then I'm going to multiply by the second piece there. If there were 3 pieces or 4 pieces or 5 pieces, you would keep multiplying until you've done all of them. Okay, in this case, we only have 2 and 2, so it's pretty simple in this one. Minus, because it's negative B times 5A. So with this one, I go negative 5, and I put them in order, A, B. Right, I'm going to move this guy down because I just realized I'm not giving myself enough room here. All right, we'll do blue because I'm trying to do completely different colors here. So negative 4B, let's multiply by the first one here. So negative 4 times 8 gives us negative 32, and AB, AB. And then we have negative 4 times negative B, negative 4B times negative B, so that's positive 4. 2 negatives make a positive. B times B is B squared. All right, so I'm going to go back to my original color here. So we just want to combine our like terms, which again should be in the center there. If they're not in the center, it's all right if somehow you kind of multiplied out of order. I definitely would suggest multiplying kind of in an order like this so that you make sure you've multiplied every piece together because you don't want to miss anything. All right, so we have a negative and a negative. So I'm going to add them together. Don't know what I'm doing. There we go. So 5 plus 32 is 37, and I keep that negative sign, plus 4b squared. All right. 40a squared minus 37ab plus 4b squared. All righty. Perfect. All right, another one. We're going to just keep on practicing these guys. So the more you practice, the better you are going to get at this. So it's just a means of practicing quite a few. That's why we put so many of them on here, is literally so you can just keep practicing them, because this is definitely an important step when we get to solving these equations later. We want to understand how we create a trinomial, because we also need to be able to take them back out when we factor them later. So there's always a forwards and a backwards in math. Keep that in mind. So negative 8 times negative 4y, negative 8y times negative 4y. I left that off when I said that earlier. So negative times a negative gives us a positive. 8 times 4 is 32. Y times y is y squared. Now I have negative 8y times 5. So a negative times a positive is a negative. And then we get 40. And just y because there is no variable over here. All right, so now we're going to do positive 3 times negative 4y. So we end up with negative 12y, because it's positive times negative, and we just tack the y on there. And then 3 times 5 gives us 15. So again, we should have some like terms in the middle here. We're just going to combine them. And 40 plus 12 is 52, and I keep the negative sign. So I'm adding them together. I had 40 negative, I'm going 12 more negative. So just be careful about that integer addition there. All right, 32y squared minus 52y plus 15. All righty. Okay, so now we've gotten to the point where they're expanding it a little bit. So this is where FOIL would stop working. If you were using FOIL, so I was using FOIL, but I just wasn't actually saying first, outside, inside, last, but it actually worked out the same way. But now FOIL wouldn't work if you were using that before. Now we have to use something along the lines of what I was doing where I was tracking it. So now, and I always like to use the binomial if I can, because I feel like it's a little less distribution. So I'm going to start with this 7u. I know it's on the right side, but it's still the same thing. So I'm just going to go ahead and start multiplying here in the front. So I have 7u times 4u squared, and I get 28. So 4 times 7. U to the third. Don't forget your power rules. This is a 1 here. So I have u to the first power times u squared. So we add the exponents because we have both bases that are the same. So we add those two exponents. All right, so now we're going to go to this guy here, and we have 7 times negative 2, so it's negative 14, and then u times u gets us u squared. And then we have 7u times negative 5, so that's negative 35u. And the only problem that I'm going to run into here is I'm writing too big. So I'm going to write this on the second line here, but just keep in mind it should all be kind of together. I just don't have quite enough room. And you know what? I can even do this. So I can give myself a little bit more room here. So I can continue to write it. So I'm going to take this 6 and I'm going to do the same thing. So I'm going to go over to the beginning and I'm going to start, for whatever reason I like that idea of starting at the beginning. You could start with a negative 5 also. It's just a preference thing, I think, for me. So 6 times 4u squared, so that's 24. And u squared, because there is nothing else to combine that with. And then we have 6 times negative 2u, so negative 12u. And then 6 times negative 5 is negative 30. All right, so these ones, it throws off that like terms in the middle just a little bit. They're still in the middle, but they're separated just a little bit here. So I have my u squareds, and then I have just my u's. So remember, they have to be exactly the same to be like terms. So I'm only going to combine the ones that are exactly the same as far as having the variable with the exponent the same. So it's negative 14 and positive 24. They're opposites, so I'm going to subtract. And then I will let the bigger number decide my sign there. So it's going to be positive u squared. And then I have negative 35u and negative 12. Those are both negatives, so now I'm going to combine them. So I end up with, didn't mean to mark the board there, 7 and 4u. So 47u, negative. I had 35 negative, I went 12 more negative. And then just the negative 30 gets kind of tacked on there. All right, so now I have to keep going back and forth. 28u cubed plus 10u squared minus 47u. Whoopsie. I forgot to hit my over arrow. Minus, yep. Minus 47u minus 30. All right. Yay. Let's keep on moving here. I'm going to scooch this back down just a little bit. Okay, so just to be a little bit of a time saver here, this is the exact same type of problem we just did. So I know I did all of these ones one at a time, but this one is exactly the same. The only difference is now the binomial's back on the kind of front end here on the left side. So you do the same thing. 3x, you're going to multiply by each piece. And then negative 2w, you're going to multiply by each piece. Make sure you're combining like terms because now we have x's and w's. So we are going to have some different like terms in there. So I'm going to let you guys work that one out because it's the same procedure as this one. We just have two variables here. All right. Just for time's sake, because I don't want to make this video super duper long. All right. So now we get some drop downs on this one. We have to do sometimes, always, never. These can be a little tricky sometimes because you really have to pay attention to what the statement is saying. So for each statement, choose one of the three options. So an integer added to an integer is an integer. And that makes sense. An integer means that it's positive or negative or 0, but there's no decimals, right? It's not decimals or fractions. It's whole numbers. Be careful with that because that's actually another section of the real number diagram there, but I mean no decimals at all. So this would be always true. That definitely makes sense. If I have an integer and I add an integer to it, it would have to be an integer. An integer multiplied by an integer is an integer. Well, that would make sense too. There wouldn't be any decimals created here if I'm not starting with a decimal. So I'm going to go ahead and click always true. An integer divided by an integer is an integer. Okay, well, with this one, I can start with an integer, and I can divide by an integer, and I'm not going to end up with 1. I'm going to end up with a decimal there, right? So this one is sometimes true. This doesn't mean that it's always false, but this is an example of it being false, because what if I had 4 divided by 2? Okay, well, now I get an integer. It just kind of depends on the numbers I'm dividing, because we can definitely end up with decimals there. A polynomial divided by a polynomial is a polynomial. And I would be careful with this statement again, because divided by means that we can get all the way down. You could get down to a monomial instead of a polynomial with this one, if you have a polynomial divided by a polynomial. So I'm going to say sometimes. It kind of depends on what we're dividing there. A polynomial subtracted from a polynomial is a polynomial. And I'm going to say always true on this one. The only thing, and this one might actually be my downfall here, is it kind of depends on if something cancels out, and then it cancels down to a monomial. So I'm going to assume they're not including that, but that could be actually the situation where this would become a monomial. A polynomial added to a polynomial is a polynomial. So this is definitely going to be always true. So if this isn't correct, I'm going to assume that it's this guy here. So let's go ahead and check it. Ooh, okay, so this was correct. So they weren't taking into account that you were going to subtract pieces and they were going to cancel out. So that was the only thing I was a little bit worried about there on that statement. All right, let's go to the next one here. Okay, so these are special situations. So I know I did a bunch of these already, but let's go ahead and take a look at these, because this one is a little different. If we notice, already we should kind of be noticing that there's something kind of a little funny here. They're almost identical, except we have minus and we have plus. So this is one of our special products. So I'm going to do that same thing here so we can see what's happening. So I'm going to take my first piece, 7y, and I'm going to multiply it. So 7 times 7 is 49. Y times y is y squared. And then I'm going to multiply by the second one here. 7 times 5 is 35. Y times z is just yz. And I'm going to make this a little bigger because I'm writing too big here. Oh, I hadn't erased all my other one. Ha ha ha. Okay, so let's go to blue here. We're going to take this negative 5z, and we're going to multiply it by our first piece here. So negative 5 times 7 gives me negative 35. And then z and y, I'm going to put them in alphabetical order. So always make sure you put these in alphabetical order. It helps match like terms later. And then we have negative 5 times positive 5, so that's negative 25. And then z times z gives us z squared. Okay, so let's go ahead and combine our like terms here, which again come back to the middle when we have binomials. They were in the middle for the other one too, they were just separated a little bit. So we have positive 35yz and negative 35yz. Well, a positive and a negative cancel out. I had 35 of them, now I've taken 35 of them away. So those cancel out, and I just end up with the minus 25z squared on the end here. So with this one, what we want to start to notice is that this looks very special. So I have 7 squared, and I have y squared. And then I have 25 squared, or 5 squared, and I have z squared. If we come back and we notice, that was the two pieces, 7y and 5z, 7y and 5z. So this is a special product, definitely. If we notice this is happening, we can use this pattern to our advantage, and we can multiply this a little faster. So if I notice, this is called the difference of squares. So I'm squaring it, but it's a difference, meaning that one's positive and one's a negative, one's a positive. I was saying that backwards, but so if I notice that, what I can do is take the first term and square it, take the second term and square it, and then just put a minus sign between them. As long as they're almost identical, so they have to be pretty much the same except for that minus and that plus sign. So and it doesn't matter if it's plus first and minus second. That's not what I'm talking about. We just have to have everything else identical except for one's add and one's subtract. All right, let's go ahead and type this guy in here. So we have 49y squared minus 25z squared. So again, this is just a special product. It definitely helps us move quicker if we can recognize these patterns. So we really want to pay attention to these ones and try to recognize them when they come up. So if now we have a little bit of a different one. This one is w plus 2 squared. So remember, this means w plus 2 times w plus 2, like that. So if I go through and I do that same thing I've been doing, I take my w and I multiply it, so I have w squared, and then plus 2w. And now I'm going to take my 2 and I'm going to multiply it. So I have plus 2w, and then plus 4. So now I want to add my like terms here in the middle. And I have w squared plus 4w plus 4. So this is another special product. And I wanted to multiply it out because it doesn't really take that long to multiply it out. But this one is another one if we can memorize this pattern. So we have w squared here, we have 2 squared here. And if you notice it, this one's not as easy to notice for me, or I think for students necessarily, is that in the middle here, we have 2 times w times 2. So it's these two pieces. We have the two terms, w and 2, multiplied together, and then also multiplied by 2, because there's 2 of them. So it's just another pattern if we can recognize it. So the easiest thing to do, and this is when we come to factoring, which we will come to this at some point, I always just bring this down and go, I take the square root, and then I multiply them back together and say, okay, 2w times 2 does get me 4w, so that works in this pattern. So again, it's a pattern recognition that will help you move a little faster as we move forward in this type of math. So let's go ahead and type this one in. Squared plus 4w plus 4. All right. Last one here. Let's see, is this one different? This one is exactly the same. So if we use that same pattern, I'm just going to go ahead and do this one. I know I just did one, but squared. So I'm not going to necessarily do the whole thing here. I'm going to go ahead and square the first one. So I have 4w squared, because I'm squaring each piece. I'm going to square the last one. And then this middle term, since it's a plus here, I know I'm going to be adding everything, so that's not going to change. But I do want to take these two pieces and multiply them together. So 2 times 9 would give me 18. W and V would give me V then W, right? And then I want to multiply that by 2 before I put it back in here. So it would be 36 VW. So not necessarily a huge time saver on this one because you have to memorize that pattern in order for it to work. So you do have to have that either written down and you understand where to look for it, or you have to already have it memorized in order to make this work correctly. All right, squared, check. And we're good to go. All right, so that was section 3 and 4. I will see you in section 5.